Good afternoon. Good afternoon. I understand, but I'm sure I'll make this session very interesting for you. It's a new topic uh, related to the electric vehicle, commercial vehicles. My name is Ripunjay Parikh. I represent Schaltbau, India, and I'm going to talk of how DC switchgear plays a very critical role in your electrical vehicles. And I'm going to talk of a case study which is comparison between two specific technologies that are available and which you should prefer. Before that, quickly to tell you about Schaltbau, we are let's say 95 years old German multinational company, primarily active in three segments: rail, new energy, as well as let's say e-mobility. We come with a pedigree from the railway, which has the severest application, whether it's shock and vibration, dust, heat. So we know what e-mobility application is. And we have a presence in India for more than 20 years now, having two manufacturing facilities. So we proudly support Make in India. Talking about the three segments, e-mobility is the new segment that we are now playing more and more active role. We know this application. Primarily, you need DC switching at the battery side, which these contactors find place in the battery units, or let's say the BDUs. And then you also need to switch it on the power side, where your power gets to the, let's say, the transmission, and that's where we call it the power distribution units, PDU. So exactly what goes into these applications we know, and we have, let's say, a line of products which primarily caters to these segments. So contactors for, let's say, low voltage application, whether it's a two-wheeler or a three-wheeler, we have the contactors for these applications. And when we talk of the higher power passenger vehicles, medium voltage commercial vehicles, buses, again, we have the range up to 1,500 volts applications. And for the larger applications, we can go up to 3,000 volts and 3,000 amperes. So this is more about, let's say, we have a product which meets each and every segment of the e-mobility. But then there is a challenge. You design your commercial vehicles, electric vehicles, to not only perform in the regular ambient conditions or the regular systems, but you have to design them to even be sustainable in abnormal conditions. Now, abnormal conditions could be on multiple fronts. It could be, let's say, the external thing. It could be the internal thing. You have heard many cases about, let's say, fire, which is attributed to the electrical failure, short circuit, and so on. Maybe it is actually on account of electricals, or it's being blamed on electrical, we don't know. But electrical fire safety, electrical thermal management, these are all very critical aspects of the electrical systems. So that is where the contactors are a very significant part, because they switch on and off. Now, when you switch an electric circuit, and I'll go a little bit into the technology, in home you get AC power, and in the vehicles you get DC power. AC power has a very unique characteristic. It has a sinusoidal curve. This means in every 10 millisecond, the voltage comes to zero, and then it comes back to the peak. So when the voltage comes to zero, power is zero, it is very easy to manage that switching arcs. But in DC, there is no voltage zero, so the arc remains, and you have to manage that arc. So there are two technologies which I want to talk about. Schaltbau believes in the air insulated technology. The other competitors go for, let's say, gas insulated technology. And this is primarily coming from China to make it cheap. One quick benefit which comes is, in the air brake, you make more distance between the moving parts, by which you manage the arc. In gas, there is no space. It is only the gas insulation which tries to reduce that arc. Now there are multiple, let's say, disadvantages and advantages for the, let's say, air insulated and the gas insulated technology. And that's what I want to cover in the next couple of minutes. Firstly, in terms of the electrical endurance, in terms of the life of the number of switches that you can do, the air brake system can manage much more, nearly 10x times the life. While in the gas insulator, you're putting a hydrogen gas to try to quench it. In the event there is a leakage, then this product actually can create, let's say, a much bigger problem like an explosion or let's say welding and so on. In air brake, there is no risk of any leakage. It's just that it is designed to handle that. And lastly, in this technology, because the movement is very less in the gas encapsulated system, your switching capability reduces to a very small extent because you are not able to manage a big amount of arc. So when we go for an open architecture, you get a safe, explosion-free ambience, because in the normal conditions these will operate. But let's say in an abnormal condition where you have let's say a fault, a gas encapsulated contactor cannot switch it. It mandatorily needs a zero current condition to switch. But in an air brake system, you will see in the next couple of slides, you will be able to manage any amount of arc. So we are not talking of, let's say, a day-to-day operation. We are talking of that one or two abnormal operations which actually creates a problem of, let's say, arcing or let's say electrical fires. Second, what you see in the air insulated system, what we talk of, we have a special contact design. We have, let's say, the contacts which are made of, let's say, silver alloy component. This gives a very high electrical life. This gives a very high thermal element, thermal capability as compared to, let's say, the air brake, which primarily depends on, let's say, copper or let's say silver plated copper. And I can say that with the technology what Schaltbau has about the silver alloy contacts, the contact warming is up to 1/3. This means we are talking of reducing the heat generation within your battery units or within your electrical vehicles to up to, let's say, 66% lower heat generation. So this is the second advantage with the air insulated technology. The third is when I talked about, let's say, the higher switching current. In the normal case, you will switch the regular rated current, which could be, let's say, 100 amps, 200 amps, 300 amps. But when you switch on, there is a surge because your motor is going to draw a very high inrush current or your system is going to draw high inrush currents. At that time, today, your inverters are primarily managing that, but if in an abnormal situation, the inverter would see the full load current, and these air insulated contactors can withstand it. A gas insulated contactor cannot handle a higher current than the rated current. They will actually burst. So that's the second important element of handling an abnormal conditions safely. So whether it's in your battery system or whether it's in your PDU, it manages this. And on the same level, when you switch on, there's a high inrush current, as I said, the air insulated technology is able to handle that, whereas the gas insulated technology will primarily need the inverters to switch off the current first and then only operate. The next important element is in those gas insulated technology, because it is a hermetically sealed device, you cannot measure or you cannot check the actual true contact position. If the contactor is welded, you will still get a wrong signal to your BMS that the contactor is on and off depending on the command. But in case of an air insulated technology, the way Schaltbau has, there's a mechanical indication for the auxiliary switches. So you get at every time the true contact position indication in your BMS. Lastly, when we talk of the future, and we were talking in the previous panel discussion in the pit stop, can we talk of, let's say, charging a vehicle online? In Europe, we use the vehicle batteries to charge and feed back to the grid or to, let's say, charge the homes. This means your system should be bidirectional, should be able to handle the current inside the vehicle. It should be able to handle the vehicle, the current from outside the vehicle. And that's where the air insulated technology primarily is a fully bidirectional. Your vehicles, your battery systems are future ready for vehicle to grid, vehicle to, let's say, home, or vehicle to, let's say, any systems. And this has been proven in Europe. Primarily, this is the norm. In India, this will come. So bidirectionality becomes a very critical aspect. And then last point, we have, let's say, economizers in our control system by which the watt loss becomes less than 2 watts. This means your continuous consumption of the power by the contactor is going to be the minimum. And because of this, I would say primarily Schaltbau contactors will result into up to 60% lower heating inside your batteries, inside your power distribution unit. So you don't have to manage those heat. And this is going to be, let's say, the best advantage. So primarily, these contactors, again, we manufacture in India, whether it's the PME drive or the other government conditions, Schaltbau confirms to that. And that's where we are, let's say, preferred by a lot many OEMs. We have a full-fledged manufacturing, 2 facilities in India. One is in Manesar and one is in Mumbai. We have sales and service presence across the country. We have in-house engineering capability. So any customer requirements, we can validate it. Any development we do, we can validate in-house and we can support our customers. These are some of the products that we manufacture. We have displayed this at our booth. So I invite each one of you to come over to the Schaltbau booth, understand and see the difference between these technologies. And we stand committed to ensure that as an ecosystem, we make the most safest electric vehicles. We give you the lowest thermal losses in your vehicles, by which the systems will keep on working in the best, in the adverse conditions also. Thank you very much. And if there are any questions, I'll be happy to take them at our booth. And I wish you all a great conference way forward. Thank you very much.